Guys, it's time. It's Tuesday, 11 a.m. Eastern, 8 a.m. Pacific, 5 p.m. European. If I was to be honest with you, I did not realize that the entire continent of Europe had its one time zone. I'm learning something, you know. I'm learning something every day. Quick mic check. It seems like it's working to me, but you can never be sure because I'm sort of in a vacuum here, just talking to a camera and about to do some experiments. So if you can hear it, hit me up in the chat, let me know. Awesome. Thank you so much, Joel. I am glad that I sound okay. Hopefully I'm in focus. I'm using this camera with a manual focus today, so everybody's learning something new. I've had a big morning. I went on a jog, which is not my favorite activity. I'm sure there are some joggers amongst you, and you spend a lot of time jogging. Thanks. I see. I'm checking the chat. I'm doing my best to stay engaged. Thank you so much. I do appreciate the compliments about the haircut. My wife is doing a great job with this COVID cut. This is at home. This is. I made a joke. I said, you know, in about 2 months, maybe 1 month. In about 1 month, we're gonna all walk around looking like jacked up rock stars that can't afford to go to their very fancy salon. Also, in about 1 month, we're gonna know what color your hair is. Mine's getting gray. My nieces and nephews love to remind me of that, and that's just thanks. That's you know, everybody's trying. So back to jogging. I'm trying to jog to stay in shape, and then I had some emergency soldering, as will happen. And then my live stream software crashed, so it's been a tumultuous morning of ups and then downs, but we're here together and we are going to talk nerd. So, who is excited about talking Raspberry Pi? This is my Raspberry Pi. This is actually not a Raspberry Pi. This is called an Asus tinkerboard, and I will show you the reason why I'm using it today. Let's see if I can get it right there. My Asus tinkerboard, the reason I like it is, can everybody see that it has colors on the Gpio pins? So these pins right here, let me bring my camera over. I'm trying to work with you guys so we can all see what I'm talking about. There we go. These pins right here, how do cameras work? Are called Gpio pins for general purpose input output, and you can power it with those pins. This board, you can look at different serial buses. In one of my other videos that is on YouTube somewhere, I used it to look at the I2S lines, which is an audio bus, but I also have these handy little slide-on adapters that have words on them. It might not be able to focus quite that closely. Let's see, can it? I'm right there, can you see it? No. Well, on here is all the signal names, and you can slide this over the GPIO adapter. So now you can keep track of what signals you are actually plugging into. It just makes it a little easier. Here on the OscopeWizard, we're all about pro tips about to try to make your life a little bit easier. And if you have any pro tips for me, please just share them in the chat. I would love to hear pro tips. One of the pro tips that I am looking for is a tool to help me make header pins. So I need to know that tool. Just let me know what kind of wrench or sprocket I need to get so I can make header adapters, and I'll show you what I mean. So this weekend, my son and I, the junior wizard, took on a big project. We wanted to, or actually he has been playing a lot of online video games, and one of his favorite games is Minecraft. Does anybody else play Minecraft? Does anybody know Minecraft? Has anybody ever heard of Minecraft? I suspect you probably have at least heard of it if you've never played it. And if you've never heard of it, please join us. Join the human race. We move out of your cave. We would love to have you so we could talk. But he and his buddy have been playing online, and they have been having a little bit of trouble getting together. So he said, Dad, please, could we make a Minecraft server? And oh my goodness. Let me, before I go on in my story, I have a tendency to ramble, and I need to set a timer, so I have this timer going to let me know how much time we have left so that you can get back to your sandwich. Minecraft server. So he wanted to build a Minecraft server, and I said, man, I have this old tinkerboard just sitting around. We could make a Minecraft server. That's something that we could do.
See, that looks good. Go, go, go.
And there is our Minecraft server right here. Actually, here is our Minecraft server. That was there. This is here. Welcome everybody. And there are some people on the chat who know Minecraft. Thank you for admitting that you do not live in a cave. So I thought that we would start by powering our Minecraft server. When you make something like this, one of the first things you need to do is figure out how to get it to turn on. And then I'm going to talk about logging power, which, what in the world is that? And finally, we'll look at the results, because when you do something, you want to see what you did. When I cut the grass, I want to see how awesome it looks afterwards. Let's go back to my setup so that you can see what I'm doing. So I have a few, let me move this over a little more. I have a few little accessories that are going to make all of this happen. I have, when you do a Raspberry Pi, has anybody on here ever done Raspberry Pi stuff before? A single board computer, or Asus tinkerboard, or any sort of thing like that? Let's see if I can get myself back in focus, and I'm back in focus. Awesome. There's a question online. Am I recording? Yes, I am recording. This will be online for everybody to see. Even people that are not my mom are allowed to watch, and I would appreciate it. So if you are going to watch, please hit that share button. That is super helpful, because I want to meet as many of you as I can. So back to the task at hand. When you make a single board computer like this, you need to power it. And you'll notice I have the classic cell phone power brick that we all get when we buy new cell phones. This one is rated for 1.55 amps and 5 volts. So let's talk a little bit about voltage and current. When I was in school, which was 1,000 years ago, my professors were trying to explain voltage and current, and my tiny mind could only think of it in terms of water. And I'm not sure why, but I think of voltage as this huge pond of water. And when I hit the on button, the water rushes forward, and that water rushing is the current. So the water is the current, and the pond is the voltage. So the pond is like the potential energy, and then the dam is the on button, and now the water is rushing. I understand it's more complicated than that, but that's all that my wizardy brain could handle. So back to turning it on. Ooh, wrong screen. So I have just a bog standard USB cable and a bog standard cell phone charger. But I do have something that is not bog standard, and that is this probe. So in the background there, of course, I'm the OscopeWizard, so what OscopeWizard show would be complete without an oscope? I have an RTO oscilloscope, and I also have this handy dandy RT ZPR40. So this is a probe specifically made to look at power rails. And since I was doing a lot of power rail stuff, I thought that I could use it. So let me get some stuff plugged in. You can still see me. I'm still here. I'm plugging this in. So I'm going to plug my USB board in. And eventually we're going to get to that power supply that's sitting underneath my Raspberry, or my single board computer here, in this case Asus tinkerboard. All right. Now before I turn it on, let me plug in my power rail probe so that we can look at it, because that one thing that we need to do as engineers is we need to make sure that things work as intended. So we design something, we build it, we manufacture it, we sell it. Now it's really important before we get it out to 1 million people to test it. So if I plug in this power rail probe into my Gpio pins, and one of the reasons I like the color grading on these Gpio pins, or the colors on the Gpio pins, is I can see really quickly that red is 5 volts. Can you guys see red? I hope you can. There's a red pin right there, and then right above the red pin is a black pin. That means ground in this case. So I can plug the power rail probe into my red pin, and then the ground side will go to ground. And now, ta-da, I'm going to be able to measure the power rail of this Raspberry Pi. And I keep saying Raspberry Pi, it's actually an Asus tinkerboard. They're about the same thing. Okay, now plug in the power, and you can see really quickly that my signal swung off the screen of my RTO, but that is no problem. I have my RTO connected to my, ooh, there we go. I think I'm in focus. Guys, my eyes are getting older, and I'm not sure if I'm in focus, but the signal's off the screen. I can't see it anymore. Let me minimize that. But I do want to find it, and this probe has a very handy trick up its sleeve. Oh, I see. Some people are sad for the signal. Poor signal. The signal's gone. Where is the signal? This is like a children's book. Where's the signal? You're somewhere, signal. Okay, probe meter. So this probe has a built-in probe meter, which allows me, even when the signal's off the screen, to measure the voltage that the probe sees. That's pretty handy. And another handy trick that this probe has is the copy to offset. So now, hello, my signal's back. Good to see you, signal. Still looking pink, still looking sharp. I like it. So let's scale this around a little bit and get it on a little bit more time on the screen. Now, I can see that signal bouncing up and down. I'm also measuring it. Does anybody notice what voltage is being measured? Can you guys see what the number that's being measured right here? Anybody? Anybody? I think I'm on like a 28-second delay, so this is a little weird. But if you do see the voltage, please just throw it into the chat so that we can all know that it is working. Oh, look, I see somebody said it, 4.78 volts, which is interesting because that power adapter is supposed to output 5 volts. And one of the reasons we test things is to make sure that the equipment is working as intended. So right now, that power adapter is not getting my board up to 5 volts, and my board wants to be at 5 volts. It is not going to operate properly for a long time at less than 5 volts. So, of course, I mean, who hasn't, does everybody have a bunch of these adapters around their house? I mean, I got, let's say, roughly 40 of these things floating around. Of course, I can't ever find them when I need them, but I do have a lot of them floating around. So let's just try a different adapter and see how the voltage changes. So same thing. This one is also 5 volts. You can see it on the screen right here. This is just another bog standard cell phone adapter. So let's plug it in real quick. Turn the camera so you can maybe see me a little more. You can see the side of my head at least, or my back. All right. My signal's gone. Again, please, signal, stay with me. Why do you keep leaving me? That's fine. My probe meter's keeping track of it, even though the signal's off the screen. If I hit copy to offset, boom, my signal's back. My scope is doing some work for me. And honestly, that scope needs to start carrying its weight because it just sits over there quietly all day long, and I need it to be doing stuff. So, my signal's back on the screen. Still got some noise on it, which is cool. But now my voltage, instead of being 4.78 volts like it was before, is reading at 5 volts. Yay! So that power adapter offers more current. So this power adapter right here that we were using to begin with, I didn't tell you this, but it only offered 1.55 amps. So it doesn't quite have the power needed to get this little tinkerboard up and running good. So this little tinkerboard, he's a hungry little guy. He needs a lot of current to go. And we are going to figure out how much current it actually requires. So now I've done some tests. I've used my power rail probe, and I have powered the Raspberry Pi up. Yay! Now I want to use my power rail probe in conjunction with my actual power supply and power the Asus tinkerboard, let's just call it the Minecraft server. The Minecraft server up. Eventually, one day, we will play Minecraft, and it will be fun. Unplug. Let's get this guy out of the way. So this guy's out of the way. Now, I want to use my power supply. So I have, let's see if I can get it. There we go. No, oh man, I'm getting all kinds of stuff. There we go, power supply. Can everybody see my handy dandy power supply? This is the NGL 202. It's a really cool 2-channel power supply that I have used a bunch in the past for data logging. Oh, I'm turning some knob that I'm not sure I'm supposed to. That I've used for data logging. I've also used for power. And today we are going to use it for data logging and power. But we'll start with just using it for power, which is, I mean, it is a power supply. So there we go. Is everybody following along? We good? We good? Hear me? See me? Good. I think we are working. I'm not sure my mom's on today, which, I mean, goodness, if I can't get my mom to join, I don't know what I should take that as. So I made this little adapter before the show, right before the show. It is banana plugs, and these are safety banana plugs. Did you guys know that there was a such thing as safety banana plug? I did not know. The last time I was in Munich, they were like, dude, use the safety banana plugs. And I said, guys, I've never heard of that thing. And then I made a not safe adapter right here that is just going to convert this little plug into these little header pins, and these are the header pins, guys. How do I make a header pin? How do you attach the header pin to wire? It needs some kind of a clamping something device, and I don't know how to do it. Anyway, NGL 202, trying to be pro, trying to be, but only mildly successful. I will plug this in again into my headers on top of the board. Same place that I am plugging my probe in. So there is power, positive, and there is ground. So positive and ground. Let's get this out of the way of the screen so we can see what's happening. Oh, kind of went off the screen there. I'm back. Let's turn the output on. So we are going to power this Minecraft server with my power supply now, and I've set the voltage to 5 volts, and I've set the current limit. So this is the maximum amount of current that my power supply will output right now. And you can adjust the current limit, but I didn't want to go more than 2.5 amps. Let's turn it on and see what happens. So output on. And there's my voltage. So my voltage is back on the scope screen. And my current is about half an... Uh-oh. What do I hear here? I think I hear somebody on the stairway. I think...
5 minutes left!
Oh my gosh, guys, I only have 5 minutes to go. So we're gonna get as far as we can get today, and then we are gonna come back to it on the next show. So please tune in again, and you can stay track. Stay on track? Stay track. I don't know what stay track is. So I'm making this device turn on. It's using between 0.5 amp and 1 amp. As it boots up, it uses different amounts of power. You can see all kinds of stuff happening on the scope. But one thing you'll notice on the scope is still measuring at 4.9 volts. And I said I wanted this thing to be 5 volts. So let's output a little bit more voltage. So I'm going to output more voltage from the front of my power supply and try to get the voltage on the oscilloscope to read 5 volts. We're still at 4.9. So I'm outputting 5.1 volts. Now I want to output 5.2 volts. Now, I'm at 5 volts on my probe meter, and on my power supply, I'm actually outputting 5.2 volts. So through this wire and all these cables and making it all the way to this board, there is a voltage drop. And this is something that plagues electronics everywhere. In fact, it's the reason why we use AC power to get from the power station all the way to your house, because we're trying to avoid voltage drops along huge stretches of line. And right here, I'm losing 200 millivolts. That's 200 thousandths of a volt. Is that better? Maybe 200 millivolts. We'll stick with 200 millivolts. So I'm losing 200 millivolts along this line when I get to this board. But there's actually a way for the power supply to check the voltage at the end of its lines and compensate automatically. And perhaps in the next episode, we will actually get to that point. I hope. So let's talk about the weekend for a second. We'll end at the beginning, begin at the end. So we started with the big stuff. What did you guys do this weekend? Did you make a Minecraft server? Did you do anything crazy? Let's see, a couple of things that I did this weekend. Played tag. So if you joined early, you probably saw that. Played a rousing game of tag. Cut the grass because I'm a dad to the bone. And speaking of dad to the bone, my son's been telling this joke quite a bit. Why was the farmer upset? Because the cows were moody. I got laughs. I couldn't hear your laughs. Y'all weren't laughing loud enough, so I finally got laughs. I sitting here waiting to hear something, and it never happened. Anyway, So we checked out some different power supplies. We used our NGL to power our Minecraft server. We used our oscilloscope, our RTO oscilloscope, and our power rail probe to measure the power, to make sure that we were not only setting 5 volts, but actually getting 5 volts on our Minecraft server. And on the next episode, we'll talk about how the power supply, the NGL itself, can keep track of the power that it's outputting and make sure that you get the power that you type in. I'm going to stay on the live stream for a little bit and chat. Otherwise, I will see you guys next time. Thanks so much for watching. I really appreciate it. Please like, comment, subscribe. Most importantly, please share. Share. Just hit that share button. It's, what is it? It's an arrow that goes, is it that way? Is that way? I'm not sure. One way. There's an arrow in there that just press it. It says the word share. Mom, the word is under the arrow, says the word share. So hit that. Thanks. If anybody sees my mom, let her know. I will see you guys next time.